Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in as we go through a review of all we've done on equations for the first couple of weeks this term. And we've done heaps of different types of equations. Equations with fractions, with brackets, with pronumerals on both sides, etc. But the goal in all of them is the same. So whenever we have an equation, whether it's really complicated or it's really simple like x plus 8 equals 16, the goal is the same. What we want to do is we want to solve the equation by finding a number that we can substitute for the pronumeral, in this case x, in order to attain a true statement. So the solution to this is obviously x equals 8, because if I substitute x for 8, so if I get rid of the x and change it to an 8, I get 8 plus 8 equals 16. That's a true statement. That's why x equals 8 is the solution. So for all the equations we've done, there's one and only one solution. So if I were to substitute any number other than 8 for x, I would get an untrue statement. If I changed x to 7, I would get 7 plus 8 equals 16. And that's not a true statement. So x equals 7 is not the solution. So all these equations have one and only one solution. Now sometimes, like this one here, you can do it in your head, but you won't always be able to do that. The answers to equations are not always whole numbers, nor are they always positive numbers. So you need to have a process to go through when you can't do it in your head. The process is that we want to undo everything that's been done to x. So for something like, let's say, 2x plus 1 equals 7, what we do is we undo everything that's been done to x, but we do this in the opposite order to BODMAS. So what I've done here to x is I've times it by 2 and added 1 in that order because of BODMAS. But when I'm solving, I have to undo it in the opposite order. So instead of adding 1 first, I need to subtract 1 first. I do that because it's the opposite order to BODMAS. And then I'm left with 2x, because plus 1 and minus 1 cancel each other out, equals 7 minus 1 is 6. So 2x means 2 times x, so to undo timesing by x, timesing by 2, I'm now going to divide by 2. But if I divide this side of the equation by 2, I must divide the other side by 2. Whatever you do to one side of the equation, you must do to the other side. And the solution here is x equals 3. I can easily check my solution by substituting x for 3 and seeing if I get a true statement. 2 times 3 plus 1 does equal 7, so I know my solution is correct. Now there's another way you can do it that I at least taught my classes, and that was using a flow chart. So if I want to solve the equation 2x plus 1 equals 7, I can draw a flow chart of what's happened to x. So I took x times by 2, that's how I got 2x, then I added 1, and I ended up with the answer 7. So to solve it, I start at 7 and go the opposite way. Instead of adding 1, I subtract 1 to get 6. Instead of timesing 2, I divide by 2. And so my solution is x equals 3. Either way you want to do it is fine. So let's now look at some equations with fractions. So these two equations that I have on the screen, they look very, very similar, and they both involve a fraction. They're actually exactly the same, but for one thing, order of operations. Because the order of operations is different here than here, I'm going to have to do things in a different order and I will get a different solution. So when I look at this equation here, I've taken x, I've divided by 5 first and then subtracted 9. So when I solve it, I've got to add 9 first. And then, of course, minus 9 plus 9 undo each other. I get x over 5 equals 12 plus 9. Now, this here means divide by 5. The fraction line means divide. So instead of dividing 5, I'm going to times each side by 5. So I'll times this side by 5 to get rid of the fraction. So I must also times the other side by 5. And I get x equals 105. So the difference is in this equation here, the second one, I haven't divided by 5 first. I've taken x, first subtracted 9, then divided by 5. So I'm going to have to undo things in a different order. So the first thing I need to do is to undo dividing by 5, because that's the last thing I did to x. So I'm going to times each side by 5. And then I end up with x minus 9 equals 12 times 5, which is 60. I now need to undo subtracting 9 by adding 9 to both sides. I get x equals 69. Now I can check either of these solutions again by substituting for x. So if I substitute x is 105 into the original equation, I get this. I put it on my calculator, I do in fact get 12, so I know I'm right. In the second one, if I substitute x is 69, then subtract 9 and divide by 5, I do get 12. My calculator tells me, so I know I'm right. You could have used the flowchart method for either of these as well. I don't mind which method you're using. So now we're going to take a look at equations with brackets. So let's look at these two equations here. They look very similar, except one has brackets. So again, they differ only in order of operations. So in the first one, I've taken x, then times by 3 to get 3x, then I've added 5 and ended up with 3x plus 5. But 3x plus 5 is 32, so I start with the answer and I work my way backwards. 32 minus 5 is 27, and then instead of timesing by 3, I divide by 3. This equation here is the same except for order of operations. So here I've taken x, I've added 5 first, and then after I've done that, I've times by 3, and that's how I got 3 outside of x plus 5. But to solve it, I'm going to do the same start at 32. I divide by 3 first. Now that doesn't give me a whole number. It's 10.6 recurring. Nothing wrong with that. The answer doesn't have to be a whole number. And then I subtract 5 and I can use my calculator and get 5 2/3. So the answer does not have to be a whole number. Again, I could check either of these solutions. I would check this first one by substituting x for 9. I check the second one by substituting x for 5 2/3 and seeing if I get a true statement. So I've shown you a way that you can solve brackets without an equation with brackets without expanding the brackets. You can of course expand the brackets if you like. So if I have something like 4x minus 9 equals 44, I can choose to divide by 4 first, or I can expand the brackets. So 4 times by x gives me 4x. 4 times negative 9 is negative 36. And that equals 44. I just solve like normal. So I'm going to add 36 to both sides. So I get 4x, of course these cancel out, equals 80. Divide each side by 4. Of course, what I do to one side of the equation, I have to do the other. I get x equals 20. Okay? So you don't always have to expand the brackets to solve an equation with brackets, but you can do that if you want. So I can use this method or this method in equations of that type. Just to make things messy, sometimes you have no choice but to expand the brackets. And that's if the pronumeral is in more than one spot. So let's use y as the pronumeral. So let's say I have 3y plus 1 plus 4y minus 8 equals, and I'm going to put a negative 2. Because y, the pronumeral, is in more than one spot, I must first get it to one spot so I can solve. So I've got to expand the brackets here. 3 times y, 3 times positive 1, plus 4 times y. 4 times negative 8 is negative 32. Okay, and I haven't done anything to this side, so it stays equal to negative 2. Now I collect like terms. So 3y and 3 are not like terms. I can't add them together. But these two are like terms because they both have y in it. So 3y plus 4y is 7y. So this is 3 minus 32, not 3 plus 32. So 3 minus 32 is negative 29. And I get that. So now that I've got y to one spot, I can solve this like I've been doing all the others. So I can add 29 to both sides, and I get 7y equals 27. So now, of course, what I need to do is divide each side by 7. That's how I undo timesing by 7. So then y would just be 27 over 7, which is 3 6/7, or 3.8571 if you like. So again, I can check this solution by substituting here and here. Y equals 3 6 over 7. You could pause the video and check that now if you like. But I just want you to understand that, like, if you're in a test, you don't need your teacher to tell you whether or not your answer is correct. You can check it yourself. Now we'll look at equations with pronumerals on both sides. So let's start off with an equation like this. 3y plus 5 equals 5y minus 9. So, when I say we have pronumeral on both sides, the letter is on the left-hand side of the equation, but also the right-hand side of the equation. So when that happens, what you want to do, as I alluded to before, you need to get the pronumeral on one side of the equation in one spot. And you do this by subtracting. And what you do is subtract the pronumeral with the lowest coefficient. So remember, coefficient just means number in front of. So here we've got a pronumeral 3y and 5y. So the one with the lowest coefficient is this one. 3 is lower than 5. So what I'm going to do, I'll rewrite my equation. I'm going to start with this equation and I'm going to subtract from both sides 3y. So I do that so that I will have a y on only one side of the equation. So 3y minus 3y is just 0. I'm left with just 5 on the left-hand side. On the right-hand side, remember, like terms. So 3y and 5y are like terms. So I can subtract them. 5y minus 3y is just 2y. I can't subtract 3y from negative 9 because they're not like terms. So I didn't do anything to the negative 9, it just stays as it is. We know how to solve this from here. We just add 9 to both sides. So 5 plus 9 is 14 equals 2y. Now we divide each side by 2 and we get 7 equals y. That's the same as y equals 7. So that's my solution to this one. Now I can check it again by substituting 7 here and here and seeing if I get a true statement. I can't substitute one of the y's for 2 and the other y for like 5. I have to substitute y for the same number. So 3 times 7 plus 5, the left-hand side is equal to 26. The right-hand side is 5 times 7, which is 35 minus 9, which is also 26. So I know that I've done the right thing. Now, if you have pronumeral on both sides and brackets, you need to expand the brackets first. Okay, so let's try a question like this. Let's say I've got 6 side of 3x plus 1 equals 20 minus 2x, okay? So I've got brackets, so I need to expand them first to help me get x to one spot. So 6 times 3x just gives me 18x. 6 times positive 1 is 6. I haven't done anything to the right-hand side. So now I'm going to follow this rule here. Subtract the pronumeral with the lowest coefficient. Now, this one here has the lowest coefficient, but the number in front of it is not 2, it's negative 2. So I need to subtract negative 2x from both sides, or in other words, that's the same as adding 2x. So I need to add 2x to both sides. So on the left-hand side, 18x plus 2x is 20x. I leave the 6 by itself, it's not a like term. And then on the right-hand side, I have 20 minus 2x plus 2x cancel out. So now I've got my equation 20x plus 6 equals 20. So you know how to solve it from here. Subtract 6 from both sides and then divide by 20 and you get x is 0.7. Again, I can substitute x for 0.7 here and here and see if I get the same number on the left-hand side as the right-hand side. Okay, now we're just going to look at how we would do it if we had a fraction on one side and pronumerals on both sides. So let's say I have an equation like this. So if you have pronumeral, in this case t's on both sides, but a fraction, what I'm going to do first is times each side by 3 to get rid of the fraction. Then I'm going to use the rule of subtracting the pronumeral with the lowest coefficient. It's just because fractions are hard to work with, and I don't want to subtract. I could do this, but I don't want to subtract a third t or t over 3 on both sides. That'll just make it hard with fractions. So if I multiply the left-hand side by 3, these two cancel out. I'm just left with t minus 4. I don't multiply the top of the fraction by 3. I just want to cancel out. So t minus 4 equals, now I have to times this whole thing by 3. So I have to times 2t by 3 and negative 18 by 3. Now I can do the process that I said before, subtract the t with the lowest coefficient. Remember, t is the same as 1t. So here I'm subtracting 1t from both sides. They cancel out. I'm left with negative 4 equals 5t minus 54. So then I need to add 54 to both sides. That's how I undo subtracting 54. So then I get 50 equals 5t. And of course my last step will be divide by 5. 50 divided by 5 is 10. My solution is t equals 10. Now the last thing I have to go through is how to solve problems using equations. So whenever you're solving an equation, solving a problem using equations, follow these steps. Firstly, let x or whatever letter you choose be the thing you're trying to find. Secondly, you've got to rewrite all the information given into an equation, and then you solve as normal. Let's look at some examples. So let's look at this question here. A maths tutor charges $20 per hour. How many hours must they work to earn $200? So we can solve that using equations. So my first step is going to be I'm just going to choose x be the thing I'm trying to find. So I'm trying to find how many hours. So let x be the number of hours they work. Secondly, I want to put all this information into an equation. Now, some of the information doesn't matter. The fact that it's a maths tutor doesn't matter. It doesn't matter whether maths tutor, plumber, whatever. It's the same thing. So the amount they charge, I want that to be $200. So I've got to put that into an equation. So I want $20 plus $30 per hour to equal 200. And I want to find what x is, which is the number of hours. This is always the hard part. Now solving it, you know how to do that. So I'm going to subtract 20 from each side. And then I'm going to divide each side by 30. I get x equals 6. So therefore this person has to work 6 hours in order to earn $200. Okay, let's look at a question that's slightly harder now. So let's have a go at this question here. 2 consecutive multiples of 13 add to 143, and what are the numbers? So here there are 2 things that you sort of need to find, the 2 different numbers. But what I need to avoid, I can't use 2 different letters because that will screw up the equation. So what I do when I have more than one quantity, in this case I have 2, always let whatever letter you want, I'll choose A this time, be the smaller quantity. So in this case, I'm going to let A be the smaller number. So I don't want to add another pronumeral to my equation. What I need to do is write the other quantity in terms of A, so it has A's in it. So if you have a multiple of 4, to get the next multiple of 4, you add 4. If you have a multiple of 7, the next multiple of 7, you add 7. If I have a multiple of 13, I add 13 to get the next multiple of 13. And that will be the larger number. Okay, so again, I've only used one letter here, which is what I want. So then my second step, I'm going to put this into an equation. So the first multiple of 13 plus the second multiple of 13 is equal to 143. A is in more than one spot. I need to get it to one spot by collecting like terms. And you know how to solve from here. I subtract 13 from both sides and divide by 2. So A equals 65, but A was the smaller number. The next smaller number, I add 13. So therefore, the 2 numbers are 65 is the smaller and 78 is the larger. And you can see clearly they add to 143. They're both multiples of 13. That's all there is to it. Just make sure you're not using more than one letter. All right, so that's all I have to say. I'll just put up a quick summary slide of everything you need to know. So on this slide is everything you need to know. You just need to be able to solve equations for this part of the test. There is another video on the other part of the test, which is on graphing linear relations. But you need to be able to solve all different types of equations using the techniques I've gone in this video. And make sure you know the steps for solving worded problems that I put in this video. If you have any questions, please let me know. Other than that, this has been the luckiest maths teacher in the world. Have a great day.